this is our volume project. This is our base region. It was created using two exponential functions. One is a negative exponential function and one is positive.
Okay.
Our exact equations were f of x equals negative x squared plus 4 and g of x equals x squared minus 1. They intersect at 2 points on our graph in our interval range. First, they intersect at negative square root 5 over 2 and 1/2, and then they intersect again at positive square root 5 over 2 and 1/2. Our interval range was given to us, and it's from the first point of intersection in the second quadrant all the way to x equals 2. So it gives us a full region right here, and then the region intersects again and then starts another region until we hit x equals 2.
And our cross-sectional shape is made up of equilateral triangles, which creates a ridge at the top of our shape. Then, as it begins moving positively, it begins decreasing, and then past the intersection point, it increases again.
Our cross-sectional shape was an equilateral triangle, so we found that we needed to use the formula half times base times height. And to find the height of each of an equilateral triangle, you multiply the base times square root 3 over 2. So in order to find the approximate value of our shape, we first measured the depth of our foam board, and we measured that to be 0.125 inches. So then we calculated that we needed, if it was 0.125 inches, we needed 40 triangles to fit within the scaled region that we created on this board. And the scale factor changed a little bit so that 2 of our grid points equaled 1 inch. So with the 40 triangles, we drew out how long each of those sides needed to be to create all 40. And we found that, and then we found all of the side lengths. And then to calculate the area, we needed the height. So we multiplied the side lengths by square root 3 over 2 to give us the height of each of the triangles. So then we did the half times base times height formula for each triangle. And then we multiplied that by 0.125, and that gave us, and then we added every single one of those values together, and that gave us our total approximate volume of 49.097 inches cubed.
And in order to find the theoretical volume, we used a definite integral with bounds that corresponded to our given interval, which was negative square root 5 over 2 to 2. We used the half times base times height formula and used f of x minus g to calculate the base, and square root 3 over 2 times f of x minus g to find the height. This process gave us a theoretical volume of 53.091 inches cubed. Then, in order to calculate error, we subtracted the absolute value of the approximate volume from the theoretical volume and divided that by the approximate volume. We then multiplied that by 100 to get a percent of 8.135%. And then finally, our inspiration was interesting. At first, we really didn't see a shape. We were maybe going to do a mountain range, but as you adjusted it, we found it looked a lot like a fish, which gave us the inspiration for our theme of Finding Nemo, or finding the volume of Nemo.
Alrighty. Yeah. There she is.
Okay. Here's another side view, and then the back view.
Just keep swimming, just keep swimming, just keep swimming, 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 swimming.